All right, hello everyone. Today we're going to be going over section 6.2, which is on factoring trinomials. So we have two objectives. Our first objective is we want to factor trinomials with coefficient 1 for the second degree term, and then we want to factor such trinomials after factoring out the greatest common factor. So typically we can use the FOIL method to find the product of two binomials. So for example, something like k minus 3 times k plus 1, this becomes k squared minus 2k minus 3. We can also write this expression in reverse. We call this factoring the polynomial, and this undoes the multiplication. So we can express k squared minus 2k minus 3 as k minus 3 times k plus 1 now instead. So we want to factor trinomials with coefficient 1 for the second degree term. So we can factor x squared plus 5x plus 6 by finding two integers m and n such that x squared plus 5x plus 6 is going to be equal to x plus m times x plus n. Multiplying our binomials on the right, we're going to get x squared plus m plus n times x plus m times n. Oh, I said m. So it's x squared plus m plus n times x. So it's the sum of m plus n times x plus the product of m and n. So comparing this with x squared plus 5x plus 6, we see the integers m and n having a sum of 5 and a product of 6. So with x squared plus 5x plus 6, we know that 5 is equal to m plus n, while 6 is equal to n times m. So we want to consider finding two positive integers that add to 5 and multiply to 6. These numbers in this case would be 2 and 3. So this would simplify to x plus 2 times x plus 3. So we want to consider all possible sign combinations for multiplying two binomials to understand the resulting sign of the terms of a trinomial. So this is just a side note. If we have that x squared plus 5x plus 6, so if it's all positive signs, this means our binomials that we're multiplying are both addition. If we have the first sign being negative, so if we have x squared minus 5x plus 6, this means that both of our signs are negative. This would be the only way we could end up multiplying our numbers to get a positive 6, but have a negative sum. If we have x squared plus x minus 6 or x squared minus x minus 6, we see that we have different signs. And our different signs, we're really going to have to pay attention to the sum, because we see in both cases we're going to end up with a negative value or a negative product, but our sum may be negative or positive. So with x squared plus x minus 6, this means that our addition, or our binomial with addition, has to be the number with the greater value. So this would be x plus 3 times x minus 2, where x squared minus x minus 6, our negative or our minus sign has to go with our number or whatever our integer that we are adding to our variable in our binomial has to be of greater value. So this would be x minus 3 times x plus 2. So some guidelines for factoring x squared plus bx plus c. This is how we'll express it. Find two integers whose product is c and whose sum is b. Then both integers must be positive if b and c are positive. Both integers must be negative if c is positive and b is negative. And one integer must be positive and one must be negative if c is negative. So we'll do an example. We want to factor our trinomial. So we have p squared minus 2p minus 15. So let's make some notes real quick. So we need two integers whose product is negative 15 and add to negative 2. So since our product is negative, which our product, negative 15, is negatives, we have different signs in our binomials. So we know this. We can also deduce that since our sum is negative, this means that whichever one of our integers has greater value, that's going to be the one that's negative or being subtracted. So let's go ahead and decide what are some factors of negative 15. So we can go ahead and write factors of negative 15. And then we also want to write the sum of these factors. So factors of negative 15, we have to consider 15 and negative 1, negative 15, positive 1, 3, negative 2, 3, negative 5, and negative 3, 5. Since we see our only factors of 15 and all positive numbers, this is going to be 1, 15, 3, and 5. But we know they have different signs, so we have to consider each difference here. So now we focus on our sum of our factors. So 15 plus negative 1 is going to be 14. Negative 15 plus 1 is negative 14. 3 plus negative 5 is going to be negative 2. And then lastly, 3 plus 5 is positive 2. Well, in our case, we have negative 2. We have p squared minus 2p minus 15. So we have negative 2. So these are the factors we're looking for. They add to negative 2 and they multiply to negative 15. So this means that p squared minus 2p minus 15 is equal to p minus 5 times p plus 3. As always, we just want to check and make sure this is correct, so let's just do our check here over off to the side because we're running a bit out of room. But we just want to check and make sure that p minus 5 times p plus 3 is going to equal p squared minus 2p minus 15. So we want to FOIL our terms, so we'll get p times p plus p times 3 plus negative 5 times p. And zoom out a little bit here. Plus negative 5 times 3. P times p is going to be p squared plus 3p minus 5p minus 15, which simplifies to p squared minus 2p minus 15. So our answers here are correct. So the factorization of our trinomial is p minus 5 times p plus 3. So moving forward, some trinomials cannot be factored using only integers. Something like this is called a prime polynomial. So let's go ahead and try and factor this polynomial, if possible. We have x squared minus 5x plus 12. So we're considering this plus 12. So since 12 is positive, but negative 5 is negative. Ooh. This means that we need integers that are both negative. And this means that they need to multiply to positive 12 and add to negative 5. So let's go ahead and kind of set up some tables like we did in our last problem. So we want to find factors of 12, and we're looking for negative factors. And let's do this. So negative factors of 12, and then we're looking for the sum of the factors. So our factors of 12 that are negative, this is going to be something like negative 12 and negative 1, negative 6, negative 2, and negative 3 and negative 4. So we can go ahead and we can add these factors. So negative 12 plus negative 1 is going to be negative 13. Negative 6 plus negative 2 is going to be negative 8. And negative 3 plus negative 4 is going to be negative 7. None of these values equal negative 5. So since none of these pairs of integers multiply to 12 and we're looking for this keyword here, and highlight that word, and add to negative 5, this is a prime polynomial. So our answer in this case is that it's a prime polynomial. Maybe let's multiply this. Let's highlight this. Oof. In blue so we know it's not the final answer. So our final answer here is that x squared minus 5x plus 12 is a prime polynomial. So we would just end our problem at this. We would say this is a prime polynomial, then we're done. You don't have to actually solve. All right, now objective 2, we want to factor such trinomials after factoring out the greatest common factor. So if the terms of a trinomial have a common factor or greatest common factor, first factor it out and then factor the remaining trinomial. So we're combining what we did in our last section with what we're doing in this section. So we're going to factor out our greatest common factor, and then whatever we have on the inside of our parentheses is what we're going to factor as our trinomial. So for example 3, we want to factor completely. So we have 4x to the power of 5 minus 2x to the power of 4 plus 40x to the power of 3. We see that x to the power of 3 can be contained in each one of these terms. We can recognize that right off the bat and do our normal prime factorization for the rest. So 4 can be separated into 2 times 2, and we're going to separate x into x squared times x cubed. Then 28x to the power of 4. 28 can be separated into 2 times 14, which is also 2 times 7. Then we have x to the power of 1, which is x times x cubed. Then lastly, we have 40x cubed. So 40x cubed is going to be 2 times 20, which is 4 times 5. So we'll have 2 times 2 times 2 times 5 times x cubed. So now we can highlight what we have in each term. So we have an x cubed in each term, which we knew already. But now we also have 2 times 2. So in this case, our greatest common factor is going to be 2 times 2 times x cubed, which is 4x cubed. So factoring this out of our equation, we'll be left with 4x cubed times x squared minus 7x plus 10. So these are the values that we are now left with. So now we are just focusing on the trinomial. Focusing. Trinomial now. So we have x squared minus 7x plus 10. We need 2 integers that multiply to 10 and add to negative 7. So since we have that they need to multiply to a positive number and add to a negative number, these are 2 negative integers. And just as before, we're going to make our tables here of negative factors of 10 and then the sum of the factors. So negative factors of 10 is going to be 10, negative 10 and negative 1, and also negative 5 and negative 2. So negative 10 plus negative 1 is going to give us negative 11. Negative 5 plus negative 2 is going to be negative 7, which is what we are looking for. So our pair of integers are going to be negative 5 and negative 2, which means that 4x cubed times x squared minus 7x plus 10 is equal to 4x cubed times x minus 5 times x minus 2. So we can now express our original polynomial, which was 4x to the power of 5 minus 28x to the power of 4 plus 40x cubed. We can now express this as 4x cubed times x minus 5 times x minus 2. And lastly, we just want to check and make sure that this is correct. So in our check, we're going to multiply out our polynomial and then we'll multiply by our coefficient. So we have 4x cubed times x minus 5 times x minus 2. This is going to be equal to 4x cubed times, and now we're going to FOIL. So we have x times our first terms, then our outer terms, x times negative 2, then our inner terms, negative 5 times x, and our last terms, which will be negative 5, negative 2. So simplifying this, we get x times x, which is x squared, minus 2x, minus 5x, plus 10, which simplifies 4x cubed times x squared minus 7x plus 10. Now we just need to distribute our 4x cubed, which gives us 4x cubed times x squared minus 4x cubed times 7x plus 4x cubed times 10, which this gives us 4x to the power of 5 minus 28x to the power of 4 plus 40x cubed. So our answer of 4x cubed times x minus 5 times x minus 2 is correct. So all right, that wraps up our section 6.2. So I'll see you all again in section 6.3.